then that's going to help them. So I'm recording it today. All right. So first of all, what I want you to know, this was just a reminder to me to record this session right here. You probably saw that, but my hair is really funky. On Wednesdays, I still run class from 9 to 9:55. It's optional. You don't have to be there. But I thought I'd have more. I only had one person yesterday. So please join us if you have questions. Now, just so you know, your quiz on 9.2 tomorrow, that I assign tomorrow, is not on Delta Math because they didn't have Rolle's theorem and the mean value theorem from 9.2 in the way that you see it on the AP exam in the way you see it in the book. And it was just too far different for me to use it. So what I did is tomorrow, like 5 a.m., I will post on Schoology. You go to that assignment and under chapter, did I say 9.4? Anyway, I'm thinking of Algebra 2. Quiz, oh, it does say 9. You're probably like, what the heck? That's because I happen to be in 9.2 in Algebra 2. So sorry, quiz 3.2. That probably makes more sense now, is a quiz that, you go into Schoology, you look under chapter 3 assessments, and just tomorrow only from 5 a.m. to midnight, it will be posted. And then you will upload your answers to me with work shown. It does say that on there. And you don't have to print the quiz. You're welcome to, but you can do it on notebook paper. It is 6 questions, usual. Then I will grade it over the weekend, and then we'll go over it in class, and then you'll see a retake if you need a retake, right? And you'll see that posted for a day. So we have to do this a little differently. Rolle's theorem and the mean value theorem are very important, and so I really have to quiz you on it. Any questions on that? Okay, any random questions? No random questions. Okay, then I think what I'm going to do, I think I want to pull my little thing over here. There we go. Okay, and I'm going to work on this part of the board. Okay, what do you need on 3.2? Let's run it through, and then at the end, whatever we didn't get to, I will do a video on. Okay,
Ms. Culver, could you do number 7?
Yes, sir. Number 7. And let me just make sure I can see it because I have part of your images on my screen. Okay, number 7. Yeah, find 2 x-intercepts of the function and show that the derivative must be 0 at some point between. Okay, yep, I can see why you would ask this one. And here's what they gave you. Okay, so here's the problem so far. And oops, that wasn't the cat this time. That was just the chair. Okay, so on number 7, it says find 2 x-intercepts of f and show that the derivative is 0 between those 2 x-intercepts, somewhere in between. Okay, so this may seem to you like, okay, how is this like Rolle's theorem or the mean value theorem? Okay, but let's take a look here. If I find these x-intercepts, and the only thing I changed is, of course, my radical, I made a 1/2 power for when I do the derivative, right? But the x-intercepts are easy to find. Where is this? So those are x's that make the function 0. So that would happen at 0, right? I see this factor here. And that would happen at x equals -4. Okay. Now, first of all, is anyone unsure of how I got those x-intercepts? Okay, You're okay there. Okay, now if I drew a picture of that, let me see. Let's see, did I set it up right? Can you see that? Yes, you can. Okay, that would be between 0 and -4. And if I asked you what these points are, you would tell me this is the point -40 and that's the point 0. In other words, I made myself, I have a function that's continuous, right, and differentiable, because x is continuous and differentiable, and the square root is for any x's greater than -4. Okay. And so, and it's on a closed interval. When they asked me to find the x-intercepts, that forced a closed interval, and f of a equals f of b. So all of a sudden, this actually is Rolle's theorem, and that's why it's here. Okay, so any questions so far before I find this? Okay, then that's the hard part, isn't it? Let's go ahead and take the derivative. All right, it looks like the product rule to me. So I'm going to take the derivative of x and keep my x plus 4 to the 1/2. Plus, I'm going to keep my x and take the derivative here. This is the chain rule, right? I'm going to bring the 1/2 out front and multiply it. I am going to reduce this exponent by 1. It is now a -1/2. If it's okay with you, I am going to place that in the denominator with a positive exponent, because if I'm going to do real math, this is easier for me. I have to, it's the chain rule, take the derivative of the inside function. It does happen to be 1. So I checked, I'm good. Okay, so if it's okay with you, then this x times 1, I'm just going to put right here. Okay, and I'm trying to find the x where the derivative is 0. So I'm going to move along, wipe this out, and put a 0 there. Any questions so far, Colin, or anyone else? I have to let people in. Hold on. There we go. Okay, so Colin, I am betting you got to this point, and then that's where it went horribly wrong, right? Okay, here's what I do. The book and website show a different way. Here's what they do. They get a common denominator here, and then they go, well, what would make that fraction 0 is when the numerator is 0. To me, they're off track, and that's too much work. I am trying to solve for x, okay? First of all, this x cannot be in this denominator then. When I get x equals, that x is in the numerator, right? Second of all, I don't like denominators. This would be an easy problem if I did not have this denominator. So that is 2 reasons for me just to multiply through by that denominator to get rid of it, okay? So I'm going to multiply each term here, here, and here by this denominator. I'm going to do that in purple, okay? I didn't leave myself much room here. So this purple goes here, right? It's multiplying here. Oops. Okay, do you see what I've done so far? Okay, now the reason why this really helps me is when you take a look here, 0 times anything is 0. So that's nice. The left-hand side is still 0, right? Right here, notice that I have a 2 being multiplied. And when bases are the same, these x plus 4s, and they're being multiplied, I add the exponents, and 1/2 is 1. That really helped me. And here, this really helped because I got what I wanted here. So just by not worrying about getting a common denominator, I don't want a denominator. I just multiply through to get rid of it. And now I have a much easier problem here, right? So let's go ahead. 2x, actually I can do better than that, right? This is 2x plus x, 3x plus 8, and when I subtract an 8 and divide by 3, I get a -8/3. That is, in fact, in between these two x-intercepts, and it was guaranteed that it would be. And if you took the time to graph this function on your calculator just to check after, and you looked where x is a negative 8/3, you would say, oh yeah, actually, if I drew a tangent line, it would have a slope of 0 there. Is that okay? Yeah, that's a really important one. Okay, another question while I erase. What's next?
Can you do 51?
Yep, thank you, Dylan. Number 51. Okay, on number 51, let's see. Use a graphing utility to graph the function on the given interval. I'm sure you could do that. Find and graph the secant line through points on the graph of f at the endpoints. Did I give all of 51, Dylan?
I think so.
Okay. Find and graph the secant line through the points of graph on the graph of f at the endpoints of the given interval, and find and graph any tangent lines to the graph. Wow, that's a lot. Okay, there we go. Number 51. Okay. Okay, so Dylan and anyone else, what I'm going to do, I'm going to make a list of what they asked for. Okay, it says to graph it. I'm pretty sure you'd be okay on that. They want the secant line. A secant line is a line that hits a graph at 2 points, and they want it to hit at the point 1 and 9. So I'll work on that. And then they want, find and graph any tangent lines that are parallel. So they want parallel tangent lines parallel to that secant line. Okay, so let's go ahead and do that secant line first. So first of all, I need 2 points that are on that secant line, and plus we're going to need this anyway. So f of 1 would be 1, and f of 9 would be 3. Okay, so I think I'll use the point slope. I can say this point slope formula, right, for the secant line. So this is what I'm working on right now, because I don't see that I have a y-intercept. So I'm going to do y minus y1 equals x minus x1. This is going to be my secant line. Okay, so let's see. The slope, I'm going to check that out. So the slope of my line would be 3 minus 1 is 2 over 9 minus 1. So let's see, I get 2/8, which is 1/4. Okay, so that's the slope. And I just want to point out that that makes sense. If I graphed the square root function from 1 to 9, anywhere where you draw a tangent line, that's going to be a positive slope and not very steep. Okay, so slope right here is 1/4. And I can pick either the first point or the second point, right, to put in. I'll pick the first one, 1, 1. So that's actually the slope of the secant line. The equation of the secant line. But for you to graph it, I'm pretty sure they put the answer in y equals mx plus b. It's not necessary. Let's go ahead and do it though. So y equals, so here's a 1/4 x, right? And I have minus 1/4 plus 1, so plus 3/4. So there's the slope of the secant line. Is that okay so far, Dylan? Kind of pre-calculus algebra 2-ish.
Yeah.
What they also want, though, is the equation of the tangent line that is parallel to that secant line. You know, and we know that this is a continuous function. It is for x greater than 0. And so because we're between 1 and 9, it's continuous and differentiable on a closed interval, right? And so this is actually the mean value theorem. The average rate of change over the interval from 1 to 9 was right here, was 1/4. We found that. And what the mean value theorem says is if we meet all the conditions that we did, there is some point where the derivative is actually equal to the slope of that secant line, the average rate of change. So this is what I'm going to use right now. Okay, so to write my tangent line, right, we know how to write the equation of a tangent line. Right, here's the slope of a tangent line. I already have the slope. It's 1/4. I said it has to be parallel to the secant line. What I just need is the point where it happens, and I know it happens in between 1 and 9. So let's go ahead and find that. Let's take the derivative, set it equal to 1/4, find the x where it happens. It's got to be in between here. Okay, so the derivative we kind of have memorized is 1/2 square roots of x. Any questions on the derivative? And I'm going to set that equal to 1/4. Now, if it's okay with you, I could go ahead and start solving this thing, but I can see what the answer is, right? The numerators are equal to each other. That means I need the denominators to be equal to each other. So this needs to be 4. So this is a 4. X has got to be 4, right? Because when I put a 4 in, the square root of 4 is 2, right? 2 times 2. So do you see where I can see the x has got to be 4? And that is in between 1 and 9. So x equals 4 is the x value where the derivative is equal to 1/4, the mean rate of change on the interval. So I'm just going to put my 4 in right here. I need the y value that goes with that. When I put a 4 in, I get a 2 there. And now I could graph all of these things. I could graph the square root function. I could graph the secant line. I could graph the tangent line. That's a lot. Any questions there, Dylan?
Nope.
Okay. All right. They will ask you for a secant line probably once on the AP exam. That's why I have this problem in here. Okay. We're going to see what's next. I'm trying to get as much done as I can for you guys so that when I do a 3.2 video of what was left over, you don't have to sit there for an hour and watch it, you know.
Ms. Culver,
Yes,
could you do 53?
sure. Number 53. Yep, the height of an object. So I'm just going to write down the main information here. The height of an object t seconds after it's dropped. That's an important word, dropped. From a height of 300 meters. So you can find the position of this object when it is dropped from, that's a T, from 300 meters up by using this expression right here. It is a physics expression. You won't ever have to write a physics expression on your own, but they do have physics in here. Find the average velocity of the object during the first 3 seconds. So that would be from a time of 0 to 3, right? So first average velocity, first 3 seconds. Now, what can confuse students here is you have a position function, and if you take the derivative of it, you will get the velocity function. But that's not what they're asking us for. They're asking us for average velocity. Average velocity is, and I forget if this is in meters. Let's see, 3 seconds. Oh, it's meters. Meters per second is what they're asking me for, right? So they're asking me for meters per second, and they want the average. That means I'm using 2 points. So what I'm going to do is I'm actually going to get 2 points from the position function and find the average velocity. And they want this for, it says the first 3 seconds. So that would be from 0 seconds to 3 seconds is what they mean by the first 3 seconds. So when we put a 0 in, obviously we get 300 out because at 0 seconds, they said that it was up at 300 feet before it was dropped. And then at S of 3, I think I'm going to need my calculator. I'm going to put a 3 in right here. So that's negative 4.9 times, when I put a 3 and 9, and then I'm going to add that to 300, 255.9. Now, notice these are meters, right? So now if I do the slope formula, because it says average, that would be 255.9 minus 300. These are meters, all over 3 minus 0. And these are seconds. And you can see then that I must have average velocity, because that's what the units come out to. And I use 2 different points. So I'm just going to do this math. And I get a negative 14.7 meters per second. So that answered, I lost that negative right there. So that answered the first question of find the average velocity of the object. Again, this is the mean value theorem. I do know that a quadratic is continuous and differentiable. It's now on a closed interval since they gave me 0 to 3. And they asked me to find the average rate of change. I see I'm using the mean value theorem. Pretty sure they're now going to ask me at what point between 0 and 3 was the velocity exactly negative 14.7 is what they're going to ask me. So on B, use the mean value theorem to verify that at some time during the first 3 seconds, the instantaneous velocity, that's a derivative, equals the average velocity, and find that time. Okay, yeah, so let's go ahead and take the derivative, which is the velocity function. Velocity equals to the derivative of the position function. And that would be a negative 9.8 t. And I'm trying to find at what time it's equal to this average velocity. So I set the derivative equal to the average velocity, and now I'm just going to divide by a negative 9.8. And that time when the velocity is exactly negative 14.7 meters per second is 1.5, right in between, which kind of makes sense, right? 1.5 seconds. And of course, it's in between 0 and 3. Right? They won't always give you a question where it's directly in between, but in this case it is due to symmetry of the quadratic function. Any questions there? All right, what's next? Half of our class is done. And I think we got some of the harder ones, the busier ones done. So we're doing super well.
Can you do number 59 next?
Sure. Was that you, Angelina?
Yeah.
Hi. Yeah, this is a good question. Okay. So again, you're reading along with me, and I'm going to get a sip of water. Hold on. Here we go. And this is something like they would ask on the AP exam. A plane begins its takeoff at 2 p.m. 2 p.m. on a 2,500 mile flight. After 5.5 hours, the plane arrives. It's at its destination. Explain why there are at least two times when speed of plane is 400 miles per hour. So I'm just going to do MPH here. So this sounds a little different to us because of the wording, but also because it says 2 times and we're used to finding 1 time where that happens. So here's what's happening. First of all, let's find the average speed of the plane over the trip, okay? And that would be, it went 2,500 miles in 5.5 hours. They took a while to say it, but that's I could find the average speed of the plane, okay? And so that is 2,500 divided by 5.5 hours. And that is 454.5. It seems silly to go so far, but I usually go to the third place, miles per hour. Okay, so normally with the mean value theorem, because obviously this is continuous and differentiable, speed in travel is on a closed interval of 5.5 hours, that this is the average speed, and you're used to them asking you, you know, at some point, is the speed exactly 454.545 miles per hour? Well, they're asking you, why is it guaranteed that there's 2 times when the speed of the plane is 400? This is due to our real world. I mean, let's think about it here, right? Here's time going by. Here's 5.5 hours, right? And here's what a plane basically does. It obviously, so people can get on, it's hard to jump on a moving plane, people, is it starts at a time of 0, 0, right? It takes off, right? Its speed increases, right? And then it usually levels out, and of course the plane lands, right? So isn't it true if the average speed was somewhere like 454.545 miles per hour, and it started from 0, didn't it have to go through at some point between here and here? It had to be going 400 miles per hour to get, if it started at 0 to get to have an average speed of 454, at some point it had to go through 400 miles per hour on the way up. Didn't it have to go through 400 miles per hour on the way down too? Because if at some point the actual speed was this, between 0 and that, it had to go through 400. And from this to 0, it also had to go through 400. Does that make sense, Angelina?
Yes, thank you.
You're welcome, because that's how the real world works. Okay, great question. Okay, what's next? Who haven't I heard from? Who's sleeping? Did you know in Mr. Brown's class, he sent us a picture the other day, and some kid had set up a dummy in his chair with a Lakeview shirt on and a Michigan hat on, like shadowing his face, but it was a dummy. It was really funny. So anyway, that's not any of you, right? You're real, right? Okay, okay, who needs, what's next? Who haven't I heard from?
Number 17.
Thank you, Star. Number 17. Okay. Yes. Okay, so I'm going to write the function first. Oh, I looked away. -1 to 3. No, I think I'm okay. All right, let me make sure I wrote it right. X squared minus 2x minus 3 over x plus 2, -1 to 3. Immediately, I haven't even looked at the question. My eyes go here. I'm like, ooh, this is discontinuous at -2. Oh, okay. -2 isn't in this interval. So otherwise it's defined everywhere. Determine whether Rolle's theorem can be applied to f on the closed interval. And if it can be applied, find the value of c in the interval such that the derivative is 0. Okay. Well, let's check out Rolle's theorem, which is just the mean value theorem where the derivative is 0 instead of some other average. Continuous, yes, because it's discontinuous at -2. That's not in here, so I know it's continuous everywhere else. It would also mean, because this is a rational function, by the way, I could also divide it, or even if you divide it, you would get a linear. It is differentiable everywhere. If not, that would kind of show up when we take the derivative. Now let's see if f of a equals f of b, because that would force the mean value theorem to have a 0 in the numerator, right? Again, here's the mean value theorem. It says, you know, somewhere if a function is continuous and differentiable on a closed interval, that if you find the average rate of change on the interval, somewhere there's an x where the derivative is equal to that on this interval. Well, if f of a equals f of b, if these two are equal to each other, then it's like f of b minus f of b, they're equal to each other, and that's 0, you know? So that's all we're doing with Rolle's theorem is we're just saying it's zero. The derivative is zero, okay? So let's find f of a and f of b. F of -1 and f of 3. All right, so when I put a -1 in here, I'm dividing by 1. So let me make sure I do this well. So that would be 1 plus 2 is 3 minus 3 is 0. And when I put a 3 in here, let's see, that's going to be a 5. And when I put a 3 in here, that's 9 minus 6 minus 3 is also 0. Okay, so the y's don't have to be 0. They just have to be equal to each other, and they are. So I do believe that Rolle's theorem works here. Somewhere there has to be between -1 and 3 where this derivative is equal to 0. So let's go ahead and do that. I'll just use the quotient rule here. The derivative of the numerator times the denominator minus, I'm going to keep my numerator and multiply by the derivative of the denominator. Thank goodness it's 1. All over the denominator squared. So this is kind of ugly. Let me check real quick, make sure I did it right. Numerator times the denominator minus, I kept my numerator, derivative of the denominator. So what makes this 0 though is just where the numerator is 0. So it's just kind of a pain in the butt. Let's go ahead and do that. I'll first clean this up. I'm going to FOIL this out. So 2x squared plus 4x minus 2x is plus 2x minus 4. Now I'm over here. Minus x squared plus 2x plus 3. So all I did was distribute here and here. So this is just like stinky algebra. Like, ugh, why am I wasting my time with this? Right? So 2x squared minus x squared is an x squared plus 2x plus 2x is plus 4x and minus 1. Okay, did I thought that I took this one off. Okay, but because I just didn't want you to spend your time with it. How many of you did not do 17? Anyone not do 17? Did I leave it on there? I really didn't mean to. Okay, so here's what's going on. Normally we would factor this, right? And, but there's not two numbers that multiply to -1 and add to 4. So what do you do when you have a quadratic and you're trying to find the x's that make, that makes this true? It's the quadratic formula. So here, every now and then that happens on the AP exam where this turns out not to be factorable, but how do I find the x's where that's true? That's the quadratic formula, where this is my A, this is my B, and this is my C. Okay, I really thought I had taken this off of here. So did you see like on 17 that the answer was super weird with the square root? Did you see that, Star? It's the quadratic formula. So I'm going to go ahead and do the quadratic formula. I thought I took this off, but hey, maybe I left it on because I'm like, this is healthy for you. I'm just going to leave that interval there. Okay. In case you haven't heard my story, here's the quadratic formula where you can find those x's. There was a very negative boy. He wasn't sure if he wanted to go to a house party. He did. He met a very square boy and missed out on meeting 4 awesome chicks. And it was all over at 2 a.m. Okay, so I think, Miles, when we were still in class, didn't we like do this on the board? We were working on memorization. So I think we did. So I'm just going to put in my values. My B is 4. My A is 1. My C is a -1. And my A is 1. There we go. So I get x equals -4 plus or minus, 16 plus 4 is the square root of 20. Yes, is the square root of 20 over 2. Then, of course, they actually did call this 4 times 5. -4 plus, so that would be 2 square roots of 5 over 2. Is anyone like, did anyone just fall back asleep now? Because you're like, what is she even doing? And then, and then x equals, this is -2 plus the square root of 5. So let's see, between -1 and 3. Oh, did I forget my plus or minus? I did. Boop, boop. You got to make that noise. I think -2 plus a negative square root of 5 would be outside. So it would just be -2 plus the square root of 5 lands in this interval. That's a heck of a one. That's a heck of a thing. All right. Anything else? Great question, Star. There's got to be more. Let's keep rolling, people. I had too much coffee. Let's do it.
Number 25.
Number 25. Yes.
Or no, 23.
23. Who is that, Star?
Yeah.
You. Number 23. So it's in the same area. Good question. It's trig. Okay. So f of x equals tangent of x in between 0 and pi. And they're asking us if Rolle's theorem can be applied. So I'm running through the conditions in my head. First of all, this function would have to be continuous and differentiable on this closed interval. And I know that tangent at pi over 2 is undefined, right? So this function actually is not, because it's undefined at pi over 2, which is in this interval, then I cannot use Rolle's theorem because it doesn't meet the conditions. But sometimes it's just easy to forget to check, you know? And literally on the AP exam, there will be one spot where you have to say that Rolle's theorem doesn't work, or the mean value theorem. And there'll be another one, of course, where it does, because they want you to use it. So this does happen, okay? Anything else there? All right, what's next, lovely people?
62.
My board is getting really yucky. Bree, is that you? What do you need?
62.
62. Oh, great question. Okay, they would do this to you on the AP exam too. It would be a multiple choice and you'd be like, where are these answers coming from? Okay, at 9:13 a.m., a sports car is traveling at 35 miles per hour. 2 minutes later, that's at 9:15. It's traveling at 85 miles per hour. And by the way, that's the way I see some of you leave the school parking lot. So, no, I'm just teasing you. So, okay. Prove that it's sometime in this 2 minute interval from 0 to 2 minutes that the car's acceleration. Now, acceleration, here's some velocities, and acceleration is the derivative of that, okay, is exactly 1,500 miles per hour squared. I'm going to call that A of t. Okay, so this doesn't exactly, again, sound like the mean value theorem, but it is, because what they're saying is first of all, is that acceleration is the derivative. They're asking us of velocity. They're asking us, is there some point where the derivative is exactly this amount? So what I'm expecting is, and if I did the average velocity, if I did the slope formula with the velocity, it would produce the same units as acceleration. And I'll show you that. And so I think what they're asking me to do is, again, speed is continuous and differentiable. It is on a closed interval. I think they're asking me to use the slope formula for the velocity, because it'll produce an acceleration, and say that there is a time in between 0 and 2 where it's this. So I'm expecting that if I do f of b minus f of a with the information they gave me, that I think I'm expecting to see 1,500. So let's give it a shot. So again, here's my A and my F of A information. Here's my B. and my F of B information right here. So F of B, the second velocity was 85. The first velocity was 35. And I'm going to put miles per hour here. And then my B minus A, here's the problem. I can't put 2 here, right? I know it's time. I know it's 2 minus 0. But now I have a problem because I have hours in the numerator and I have minutes in the denominator. So I can't. In fact, I need to keep it hours because that's what that's what they're asking me to compare it to. So this 2 minutes, I actually have to write as an hour. 2 minutes is what fraction of an hour? All right, class, 1 minute is what fraction of an hour?
Would it be 1/60?
Yeah, and so
But then
2 minutes, good. Oh, thank you, Ava. And 2 minutes would be then what fraction of an hour?
1/30.
1/30.
Yeah.
Good. Thank you. Thank you. Ava's typing it in. Way to go. 1/30. There we go. So notice, and this is hours. So notice now I do have the correct miles per hour squared, and 85 minus 35 is 50. And rather than divide by 1/30th, I'll multiply by the reciprocal, and I get that 1500 miles per hour squared. So the average velocity over this interval, right, caused a 1500 mile per hour squared. So there has to be some point where the acceleration between those first 2 minutes actually was 1500 miles per hour squared. Was that you, Bree Wrestler?
Yes.
How's that?
It's good. Thank you.
You're welcome. How are we on, oh, people, we are on fire. What's next?
You do number 15.
Did you say 15? Yes,
Yeah.
15? Yeah, 15, absolutely. Okay, on number 15, yeah, I'll write it first. This is a great question. And it's from -8 to 8. Okay, so they're asking us, there's a couple ways to go on this, Brendan, and it's just the order of doing it. They're asking us if Rolle's theorem applies. Rolle's applies, that's an S. And if it does, is there an X in between -8 and 8 where this function is, where the derivative is 0? Okay, so here's basically what happens. When you look at this, this is not, you're familiar with x squared, you're familiar with x cubed, you know that those are continuous and differentiable on a closed interval, right? So x to the 2/3, you're kind of like, well, I'd just be squaring something and taking the cube root. Any x I put in there, yeah, I can do that. I believe this is continuous, and I'm led to believe, because it looks polynomial-ish, that it is also differentiable. So I'm just going to keep rolling. I'm going to say this is continuous and differentiable on a closed interval. Let's see if let's see if f of a equals f of b. Notice that it does, because when you put in a -8, the cube root is -2, squared is 4, -1 is 3. Notice when you put it in 8, right, because of the squaring, you get the same output. Is that okay so far? Okay, so I think that Rolle's theorem applies. So I'm going to go ahead and take the derivative. I'm going to bring the 2/3 out front and multiply it. I'm going to reduce that exponent by 1. That's a -1/3. I'm going to write it here. And now, and then 0, right, when I take the derivative there. So I'm looking for where the derivative is 0, because according to me, it's guaranteed, right? So I'm looking for where it's 0, but all of a sudden I see that there's a problem here, because there's no way this fraction is 0, the numerator's 2. So I'm like, where did I go wrong? What's wrong? Here's what just showed up, right? Because we don't have really common knowledge of x to the 2/3, is when you look right here, this derivative is actually, x cannot be 0, right? This derivative is not defined at 0. And 0 is in between -8 and 8. So actually what happened, we just didn't catch it the first time around, is that this is in fact continuous, but it's not differentiable at 0. And so we can't use Rolle's theorem. And in fact, if you graphed it on the calculator, it looks like this, where the derivative is negative from the left of 0 and positive from the right, and it's actually not differentiable. If we had just taken the derivative first to check if it was differentiable, we would have caught it, but we caught it eventually. Any questions there? Okay, what's next? How we doing? I can get, oh,
Number 37.
37. I can get like 15 more of these done. Number's 37. Let's take a look. We do not, I really felt I took off number 37. No? Did I?
Yeah, you did.
I did. So Star, I must have not taken it off, or you wrote it early. I really felt I took off 37. I'll have to be more careful and make sure if I take it off somewhere, I take it off everywhere. So I'm so sorry. It's gone. Okay. Can I have another one?
43.
43. Let's see. On 43. Yeah, so f of x equals x to the 2/3. This is a great question. Did I assign 43? Okay, all right. Determine whether the mean value theorem can be applied on the closed interval. Okay, so let's take a look here. First of all, the mean value theorem, that means that this function would be continuous, and it is on a closed interval. Now, this is a small little point they really won't make on the AP exam. It's continuous and differentiable on a closed interval. And you may be like, okay, yeah, this is continuous. I can put in any x. You may say, oh, wait a minute. But based on the last problem, the derivative of x to the 2/3 is 2/3 x to the 1/3, right? We just took the derivative of that and a -1, which was 0. And you may say, oh, this isn't differentiable at 0. This is a very minor point. They won't do this to you on the AP exam. Is when we're looking for continuity of a function to use the mean value theorem, it has to be continuous on a closed interval and differentiable on an open interval. So meaning not including 0. Why is that? Because a derivative means the derivative is the same from the left and the right of a point, right? And I can't do this on this closed interval. I can't approach 0 from the left. I can't approach 1 from the right. So this actually is continuous on this closed interval and differentiable on that open interval. Okay, very picky. They won't catch you on this on the AP exam. Okay, so according to me, then I can actually do this. So let's see. So I'm going back to the original function. F of 0 is 0. F of 1 is 1. So I'm going to find the average. That would be 1 minus 0 over 1 minus 0. So this would be the average rate of change. That's what I was trying to say. On this interval is 1. And apparently there's a place where the derivative I wrote right here, there's an x where it happens between 0 and 1. Okay, so I'll multiply both sides by 3x to the 1/3. Get rid of that denominator. Okay, I'll come on up over here. 3x to the 1/3 times 1 equals 2. Divide by 3. X to the 1/3 equals 2/3. Guys, how do you get rid of an exponent of 1/3, what's the inverse operation?
Cube root.
Cube. It is the cube root.
You cube it, sorry.
Thank you, Nathan. So we're gonna cube it, and that's how we get 8/27. And it doesn't occur between 0 and 1. Okay, again, very minor point right here. This won't happen much, but it's good to talk about because we kind of blow over it. Any questions there, Star? Or Star, you would ask that.
No, I don't have any questions.
Okay, 4 more minutes. Can I get one started or one done? And then I'm going to see what we didn't get to, and I'm going to put it on.
60.
Do I have a last question?
63.
63. I took that one off. Right, class? Are there other people who didn't have a 63?
Yeah, you took that one off.
Okay, Star, sorry. Wherever you looked, I'll be super careful. Did you print something up from earlier? Anything, Star? No,
I think I looked on the like under materials or whatever.
right.
And, yeah.
Under the schedule, I'll be much more careful about changing that. Sometimes when I look at it the night before, I'm like, no, those are too complicated for remote. You know, let's get back to basics. So I'm so sorry. Any,
73.
pardon?
73.
73. How's our time? Okay. What I'm going to do then is on 73. Oh, let's do it real quick. And then I'll get a really quick list of what you guys need. Okay, so this is kind of cool. On 73, they give that the derivative is 0 and the function goes through the 0.25, and they want to know what is the function. They want the function that has a derivative of 0 and goes through the 0.25. So who can tell me when I take the derivative of an expression and it gives me 0, what kind of expression was that? Give me an expression that when I take the derivative, I get 0.
Linear?
If I had like 3x,
Constant.
2, I would get a 3. So I need a 0 out.
Constant.
A constant. Good. Okay. So isn't it true? Any constant right here, when I take the derivative, I get 0. Okay. Now I need this function to go through this point, right? And an f of x is a y value. What y does it need to go through?
5.
5. So let's take a look. Is the derivative of f of x equals 5, 0? And
Yes.
if you graphed it, does it go through the 0.25? There you go, kind of working backwards. All right, class, what did we not get to that you need a video of? Start shooting them out or throw it in.
75 and 76.
75 and 76. What else?
Can we do what, 29?
29, absolutely. What else?
31.
31. Thank you. Was that Ethan?
Yeah.
Hi. Let's see. What else?
19.
19. And I see a 47. Good. What else? Thank you, Ashton. I saw the 47. Any more?
18.
15?
18.
18? Thank you, Claire. Any more? Are you sure? All right, you have a great day. I'll have this video for you today. Okay? Bye. Thanks for hanging out with me.